Okay, welcome back. We're going to be adding some functionality here, moving into movement event 5. We take a look at what we did yesterday. We can select a first movement grid. We can drop as many as we want in there. But when we press enter, it's not actually doing anything at the moment. And that's because we haven't done that yet. we haven't done it yet because there's one more thing we got to keep in mind, and that's if we are at an edge, if our first movement lands on an edge, then we have to make sure the player drops all their occupants before pressing enter would actually switch to a movement event 5. So if we replace our grid 3-3 here with grid, let's say one higher, so grid 3, or actually it goes row, then column, so grid 2-3, oh shoot, I'm trying to replace 3-3 with 2-3. Okay, so if we do that, now our tester should be one higher, and that means our first movement grid would be on an edge, meaning if we press enter, we would have to drop all stones. What the heck? I don't know what's happening. I don't know what's happening there. We're setting our occupants, we're setting our members. So what's happening there? Oh lordy. Shoot. What is this mouse grid occupants that we're printing up? It's the occupants of the grid where our mouse is hovering over. Bro, we should have tested this a long time ago. We should have moved our tester stack a long time ago because this is just so jacked. Okay. Why is our orthogonal moves just not working? It seems to mess up on a move event 3. Look at this. Okay. Okay. This a little, just threw a wrench into everything. I was ready to get going on a new feature, but this is jacked. So we gotta fix it. I'm not exactly sure what's wrong. Something's happening when we go to movement 3, which is our... No, it's after that. It should be in movement 4. No. What the heck? Let's try to pinpoint it when it starts to mess up, because I didn't change anything, man. Why is this crashing now? What is happening? Okay. I don't know why that's crashing so hard. I'm kind of curious. If we take out all our testers and then just try to move a stack by itself. So if we try the middle one here, we're not even getting... Oh, we have to lock it in, that's right. To lock in how many stones we drop first, which seems to be working right. And then we're able to drop, yet we can't see a white on a black stone. Okay. So why is it when we have our 10 stack, why is that happening? That's in a movement event too. It's messed up that bad. No legal moves at all. So as soon as we click on a stack in our control, it's crashing. I'm kind of curious if we replace this with even one higher. So replace, we do this with a grid 1, 3. Now, let's see. If that one's the same kind of jacked up. Yeah. Well, if you look, it's thinking that the movement origin's over here. Why does it think that the movement origin is 3, 3? Movement origin should be this 3, 1 here, or 1, 3. It should be 1, 3, not 3, 3. But then even though it's 3, 3, 3, 3 would be over here. So we're not updating our movement origin correctly in at the end of our movement event 1. Movement origin row, movement origin column, and is that what we're printing up? Movement origin row, movement... Oh! Well, first of all, that would help. So that we can see the right value that we're doing, but then... Let's see this. Okay. Movement origin row is now 3, 1. Not 1, 3, so we got these backwards. Come on, where's our movement 1? Movement event 1. Here. we need to assign these backwards. So row is actually Y, column is actually X, and now it should be working. And we'll see if legal move gets set to false also. It does. Okay. So now once we lock in how many stones we got, now we're rendering the appropriate stuff. Okay, so we just had one thing backwards and we weren't able to find that bug because we were doing our tester stack in grid 3-3, and if you swap 3 with 3, nothing's different. So it was only working right there in the middle where we were testing everything. So that's a good, maybe that's a point towards maybe randomizing the starter stack or the tester stack. I don't know. Anyways, okay, now we can get to where we were at the beginning of the episode, which is we need to detect whether the first movement grid is at the edge, and if it is, pressing enter will only advance the move state, the movement event, if we have 0 occupants left in our mouse grid. But you know what? That's actually not right. That's actually not right. For example, because our first movement grid would be in a edge, just like this. We'd lock this in right here. Our first movement grid would be an edge, yet pressing enter should advance us to movement event 5 because there's still room on the grid. So we might have to implement something using our direction, our locked in direction, but I'm actually not sure how to do this anymore because it's a little trickier than I thought. Because if we had a tester stack at 3-3 here, or if we had a tester stack right here, then if we lock in our first movement up here, then that's a scenario where we would need to ensure that we drop all occupants. But that it's not as simple as just whether or not it's at an edge here, whether our first movement is at an edge. It's that if the next movement, considering our direction lock, which for right now is we actually didn't lock in our direction just yet because we didn't do this, but if we, for example, do this, we have a right lock true. So we have to at this point where we're able to drop moves where we're able to drop stones into our first movement, we have to check what the next grid would be. So like, what if we increment our grid stone or our first movement grid, like if we have a variable called next row, next column, if that next row is less than 1, we need to make them drop all their stones. If their next row is greater than 5, we need to make them drop all of their stones. Meaning, like, if our space after we lock in how many stones we drop, if that next space would be off the board, then we need to ensure we drop all of our occupants. So maybe we do have this next row, next column sort of deal. Let's try that. Let's try that idea, because we kind of have to do something like that. We have to kind of project what the next grid would be, and if that grid is not a legal move, then we have to ensure we drop all the stones so that we can swap the player upon pressing enter rather than advancing to movement event 5. I'm going to add another debug option here so we can print up our how are we doing this debug option real quick? Debug option gets 1. If it's 2, okay, so yeah, we need to add a 3. So like else if love.keepword is down. If 3 is down, we want to render this third page of debug data. And we do that by assigning our debug option to be equal to 3 here. At which point this will be true, and we can actually see what we're printing up here. And what we're printing up here is going to be that next move row and next move column. Okay. And we would put in the next move row here and next move column here. Shift it downwards so we're not just typing it on the same place. Now we need to initialize these probably as nil until we assign them. So for right now, I'm just going to put them here next to our directions because they kind of go together with that. So next move row gets nil. Next move column gets nil. And these two also need to be reset upon an R reset. Actually, yeah, upon a player swap reset. So let's just put it right here. Okay, so I think as soon as we lock in, actually, as soon as we move, let me me see this. I need to see which part of the code we need to do this for. So for right now, we don't know what our, and by next move, I really mean the second movement row and second movement column. But it might be nil, so I'm kind of like hesitant to set it to that. But let's see when we would have to set it. We would lock in our stones. We're in a movement event 3 now. So as soon as we go into movement event 4, that's the moment we would know that our next row and column would be this grid 1, 5 in this scenario because we have a right lock being true. That means we would increment our column. If we had a bottom lock be true, we would increment our row. If we had a top lock true, we would decrement our row. If we have a left lock, we would decrement our columns. So we got to kind of do that here. Right under, at the end of movement event 3, we hit enter or whatever. And if it's not actually, I haven't even seen that. It's just that if we click on a legal move, that's when we lock in our first movement. And as soon as our first movement is locked, we can actually probably add this to movement event 3, but putting it in movement event 4 makes a little more sense to me. So that's what we'll do. We'll say we'll have to assign these to be the right thing. And we know what the right thing is based on our direction locks. So we'll say if up locked, is that what it is? If up direction, then do something. else if down direction, do something else, else if left direction, else, and if right direction, do the last thing. But we don't want to keep updating. We don't want to do this more than one frame. We just want to do it once. So I'm going to also put if next move row is equal to nil, that means we haven't set our next movement row yet. Therefore, we would set our next movement row and column, and then it wouldn't be nil, and then this wouldn't get assigned every single frame. So like we would only do it once upon switching to a movement event 4. So if let me think about this. Yeah, if up direction is locked, we stay the same column. So we need to assign our next move column to be equal to our first movement column. That's easy enough. But if an up direction is locked in, then our next move row needs to be decremented by 1. Next move row needs to get decremented by 1. Now, if a down direction is locked in, we are in the same column. We're in the same column, we're just up on a row. So we would say our row gets incremented. And then we would lock in our next move column at our first movement column, just like the other one. If our left direction is locked, we're in the same row. So we need to copy over next move row gets our first movement row. Those are going to be the same, and same with the right direction, because if right's locked, it stays in the same row. It's just moving, different columns. So we're going to add that. And then if a left direction is locked, we know that our next move column needs to be 1 less. So next move column needs to be 1 less than our first move. Our first movement column minus 1. And I just realized that we did this wrong. This needs to be our first movement row. Same with this. Okay. Now, if right direction is locked in, we need to increment our first movement column and store that in our next move column. So first movement column, incremented. Now, as soon as those get populated, one of those will get populated upon a movement event 4 switch, then it will no longer be nil. So it'll only populate that one time. Let's see if that's working. 645 right here. Okay, let's try it. So next move row is nil, but as soon as we click on this, the next move row is 1, next move column is 5, so it should be 1, 5 if we project our move out 1 more. And 1, 5 is this grid, so it looks like, at least for now, our right movement lock is working. I'm going to assume we did the logic right for the other ones. We can test it, but I'm going to first of all test what we really want to do, which is say if our next move row is greater than 5, then but we also want to see if our next move row would be less than 1, then we need to ensure, like, do we do a variable here called end of the road, or no more legal moves, or like yeah, what variable would we kind of toggle here? We could also do it, yeah, I kind of do want to do it on a variable. I don't want to really put our enter logic into this space, so we should just kind of toggle a boolean at this point. So if next move row is greater than 5, we know we're off grid, right? So off grid would get true. If we're and off grid would really means that the next move would be off grid. But since we're testing, we need to be able to test it in this movement state. So we're kind of using it here, but off grid will get true also if our next move row is smaller than 1. But we need if our next move column is greater than 5, we also need to become true on the off grid, and we need to if our next move column is smaller than 1, meaning off grid, we would become grid true. So this line of code, let's initialize this first before we forget. We'll put it right after our next move stuff, and we'll initialize it as false, and we'll put it for the player reset as well, so we don't forget that. Okay. I'm also going to print this up in our debug 3. So now off grid will be true if the next move would be off grid, and that's how we're going to be using. That's how we're going to be toggling that. If off grid is true, that means the next move would be off grid. Therefore, enter will only shift movementEvent to 5 if our occupants on our mouse stones is 0. Otherwise, pressing enter will do nothing, because we have to make sure that that player drops all their stones, and then that would advance and swap the player. So let's test whether or not that's true. So we're up here, we lock in our move, we lock in our first movement grid. Now our off grid is false here, which enter doesn't do anything at the moment yet, but let's move our grid over 1 and see if over 1 to the right, and see if off grid gets true there. And if it is, then we can worry about that logic grid. Oopsie, grid 2, 3, I believe. Ooh, see, I gotta be careful not to overwrite any of that logic. We have to be really careful not to do any testers at 1, 2, or at any corner case. Well, no, not quite. We just have to be, we have to be careful, because when I've been replacing tester stacks, I do a find and replace, and it could be finding and replacing this stuff. Okay, we'll just be more careful upon the replace, which for right now it's 1, 3. we need to find and replace these, but only oh, come on, where is find is Command F, and replace is Option Command F. So if I hit Option Command F, we get both, and then I can hit. We just want to make sure there are no other grid 1-3s in our code that we would be overriding. Oh my god. Okay, just those. So let's move it over 1 to our 1-4. We'll replace all those. And now we're going to be testing, making sure that off-grid gets true, because the next move, if we were to lock in that first movement right here, we were able to lock that in. So at this point, off-grid should be true, and it is. Therefore, when enter is pressed, if off-grid is true, we need to have mouse occupants at 0 in order to swap our player. So now that we've got our off-grid working, at least over there, so I'm moving in for okay, yep. So here's our off-grid stuff. I'm going to put that this line of code detects whether or not next movement is off the grid. And then we need to do something at the end of here. So still in our movement event 4, we need to say if love.keyboard that was pressed is either enter or return, then we need to check if we are off grid or not. If off grid, then if mouse stone occupants is actually equal to 0, equality operator, not assignment. If mouse stone occupants is 0, then at that point, pressing enter would swap the player. But it would do more than that. We would update our stone control, and we would update our stack control because we would be leaving stones in our first movement grid. So we would pass in our first movement. Actually, let's take a look at what our update stone control takes in. I'll look at this. First movement grid. Oh, this is just pseudocode. Here we go. Grid at. Okay. So we do grid at first movement row, first movement column. So let's do that. Just takes in an occupant. So we have to pass in the actual occupant. And that would mean that it would be the grid at first movement row, first movement column. And then same thing for our stack control. And then the last thing we would do is swap our player, which we run this function, player swap grid reset. Which, let's just take a look at that. It swaps our player, it falsifies all legal moves, it flushes all move locked highlights, and it resets a bunch of variables for our movement stuff. So I'm hoping now we can, since our off-grid would be true in this scenario, it would force us to drop all of our stones before moving on. If we press enter, nothing happens, because if we move to movementEvent 5 right now, our next grid would be off screen, and that can't be allowed. So I'm going to keep pressing enter, and only once we have no milestone occupants is it the next player's turn. But I want to also add this, which is our move type gets reassigned to move type of place. And then I want to see if we're rendering the correct color stone and make sure that's working. So we have one stone left, pressing enter doesn't do anything. If we have no stones, pressing enter does nothing. But if we drop all our stones, pressing enter will switch our player. But if you look at this, our occupants no, we are updating our occupants appropriately, but for whatever reason, we're rendering a red highlight there, which we shouldn't be able to place a stone in there like that. So I'm kind of curious why that's happening, because we have the right amount of occupants. It's just that we're doing something wrong here. If players 1, where do we do? This isn't where we need to do it. Where are we doing? We have a field called selection highlight. That is that red outline. So selection highlight is getting true here. Where is this? This is after. Okay. So I'm going to say that this, it's weird that it wasn't highlighting on the other grids, which is really weird, but we only want selection highlight to be true if move type is place, and our mouse is over this current grid, but also that the grid at mouse Y grid, which should be row, and then mouse X grid, which should be column, if that grid's occupants is equal to 0. We should not. Actually, it does not equal 0. Well, no, selection highlight would be true if it is 0, yes. Let's see if that fixes this. So we drop all of them, and we are no longer rendering that. How are we placing a stone in there? It wasn't even rendering it. We need to see. That's a little wonky. I don't know why that's happening exactly. Let's see in our move type place logic, when we click on it, how we decide to actually here. See, look at this. This is where it is. If mouse is pressed in a move type place and the grid is not occupied. So is our grid technically not occupied? Yeah, it is technically not occupied according to our code. Let's see if we're printing up that occupied. We are not. just to show what's happening here, I'm gonna print out in our debug 3 our .occupied field of our occupant that is under our mouse. So grid at mouse Y, mouse X in the occupant field, no, occupied field. We're going to be printing that up, occupied, because we're actually not technically occupied. We become occupied when we place a stone in there, but not when we move stones into a grid, which is a thing we forgot to add. So right here, look at these two are occupied, which is right. Yet when we drop stones in there and when we lock those stones dropped in there, we are .occupied false, which we do have occupants in there. We have 5 occupants in there, so it knows there's stuff in there, but our occupied field is false. So either we say something like, we go through all the grids and say, hey, if there's any occupants, then we're occupied, or we just tackle. Actually, I'm thinking we might want to do that overall fix, because if we move our whole stack out of a grid, we want that grid to be no longer occupied so that we can place a stone in there. So maybe we do just go through the whole thing. Then that's every frame. We don't really want to do that every frame. We just want to do it upon a moving of a stack. So we need to add occupied getting flushed to false if we leave all of our stones, if we take all of our stones out of a space. So we need to both assign occupied being true if we place stones, and we need to falsify occupied if we take all the stones out. So where would we do that? Now, right here, I'm gonna say, if enter is pressed, that means we know that this is gonna be occupied at this point. So that's fine. That's easy enough. Occupied gets true. But how would we know if we took all of the stones out of a grid? And we would know if we would both have to pick up, we'd have to pick up from a stack that's 5 or less. So we'd have to pick up from a stack that's 5 or less, and we would have to not drop any stones in our movement origin. Which move event is that at? Movement event 2. Movement event 2. Yeah, we would, if our mouse stones is 5 or less, and while we're in a movement event 2, if our mouse stones is 5 or less, no, because our mouse stones are 5 or less right now, and yet it would still be occupied if we leave this grid. We do update our occupants of our movement origin grid, which is good. So we can actually do before we swap players, we can check all of our grids. Well, we don't need to do that because the only one that could be no longer occupied is this movement origin. So as soon as we are about to swap player like this right now, we need to ask, by the way, are there any occupants in movement origin? And if there are 0, then we need to become false occupied on our movement origin. So we need to say grid movement origin row and our movement origin column. At the point of swapping players, if our movement origin dot occupants is equal to 0, we moved. So like if by the end of our turn we moved all of our occupants out of this movement origin, meaning we picked up all 5, and there were only 5 or less to begin with, we pick up all the stones, then we know we need to reset our movement origin row and our movement origin column occupant to be no longer occupied. And it makes sense to do this right before we swap the player. We just have to remember to do this if enter is pressed and we're not off grid, which we would need to occupy these as well. So we can worry about that when it comes to it, but this I'm hoping will fix the problem. Let's test it, which we would need like a 5-stack or a 3-stack tester. So I'm gonna say we're gonna give ourselves this 3-stack tester and turn off our 5 or 10-stack, and then now on our page 3, our dot occupied is true for that grid, which is true. And if we leave only 1 stone there and then drop all of our stones, lock in that move, we're not switching players anymore. Stone occupancy is 0. Oh, we'd have to be off grid, so let's go to the right. Let's go to the right and do that, because yeah, that's correct. So if we go to the right, but we leave 1 stone in our occupant in our movement origin. Look, if we right now our debug 3 says we are occupied there, and then if we lock that in, we are occupied there still. And then I want to test right now where we put this back on. Actually, now we need to test it and make sure that's running as expected. So look, we leave 1 there. We dump everything here because we have to, because it's the off grid. And then if we hover over this, we are occupied, true. Now, oops. Now if we take all of our stones out of our movement origin and we move all of our stones over here, now the grid we came from is occupied false, which this is really interesting that we're rendering a blue or a green value here. That means we're not flushing our movement grid highlights, or what is it? We also need to set this legal move highlight, because that's the bright green one, to false. Because it might be rendering the red underneath there because there's 0 occupants, but the green is overriding it. So I'm just going to say right here, we're also going to overwrite our legal move highlight for our movement origin row. So this legal move highlight gets false. So now we shouldn't be rendering that green anymore, and we hopefully should be rendering that red to be able to place something there. So we move all of them out, we lock in our stones, we select our first movement, we drop them all. Now on debug 3, we are no longer occupied and we're rendering the red as correct. Now, can I place in that? Yes, I can. So that's looking like it's right. So we've done the hard case of if we're locked into a corner, forcing us to drop all the stones, but if enter is pressed and we're not off grid, then we need to do, and I like being verbose about it up here, if not off grid, just because it's easier for me to read. It's a little redundant. We could just do it else, but I like seeing if not off grid, and then I know what this code is doing right away. So if we're not off grid and enter is pressed, we actually have to make sure that we've dropped at least 1 in our first movement. So if not off grid and dropped in first movement is greater than 0, meaning we dropped at least 1, that's when we would update our stone and stack control of our first movement. So we need to update that, and then we would need to also make sure that we become occupied, and then we need to also we would not swap our player, but we would change our movement event. So movement event 5, movement event would get set to 5. And then we can actually probably lock in our second movement at this point. Okay, so our second movement, we need a couple variables, but we'll just do it here. We'll say our second movement row. We need to lock in our second movement row and our second movement column. And we need to lock them in depending on our direction. So if up direction, we need to do one thing. Okay. And if it's up direction, then and so the thing is, we know we need to assign both of these variables. If this is, we just know we need to update these two variables in every scenario, because our second movement will never be the same as our first movement. We just need to make sure we update it correctly. Now, we would say if up direction is locked, we keep our same column. Is that right? If up direction is locked, we stay in the same column, we just shift rows, yes. And same with down direction. Now, if left direction, we stay in the same row, just different column. And then here's where the magic happens, where we say up direction would be movement row -1, and we know we can legally -1 from this and have it not be nil because we're checking against our off-grid here, so we should be fine there. And then row is incremented if it's a down direction, and then our column, if it's a left direction, our column gets decremented, and if it's a right direction, our column gets incremented. So now our second movement row and column should be populated with the next movement grid, which will help us in our movement 5. I'm just going to print these up and make sure I'm doing that right. Movement row and movement column. And we need to print them up on our debug 3. This is so we need our second movement row. And then we need our second movement column. Second movement column. Okay, now before we forget, we need to actually initialize these and reset these so that we don't accidentally give ourselves bugs, mystical bugs in the future to find. I'm going to put, we need to initialize our second movement row. And our second movement column. And on a swap, we need to reset them. Okay. So I'm hoping now we can hit enter in a left direction in this current, oh, come on. 1270, play state 1270. $1070, 1270. We just left our stupid stuff up here. Okay. Now I'm hoping we can move left. And if we move left, and only one occupant is in our thing, we move movement event. We need to actually, yeah, our second movement row was 1, 2. Okay, I think that's right. But what we do need to add is that if we drop in all of our stones and it's not an edge on and off grid, that we actually swap our player. So we need to add that real quick, and then I think we're done with movement event 4. So right now we have, if enter is pressed and we're off grid, if right here, if we're not off grid and we've dropped at least one in our first movement. Okay, yeah, so we need another else if, and that's if. This is just swapping our movement event, but we actually have a possibility to swap turns here. That's if we're not off grid and our mouse stone occupants, actually that's wrong, mouse stones dot occupants is equal to 0, and we're not off grid, then what we need to do is actually just player swap. But we would want to update our stack control, we'd want to do all this good stuff. We'd want to update our stack control, update our stone control, make sure we're occupied there, and then we reset. So now, if we, there are 3 options upon pressing enter. First of all, enter will do nothing unless you are off grid and your mouse stone occupants are 0, meaning you dropped all of them in the edge. Or if occupants are 0 and you're not off grid, meaning it's just a legal move, you just drop all your stones and end your move early. Or if you're not off grid and you've dropped a stone, but you still have an occupant. So let's try those. So pressing enter does nothing, and I keep pressing enter, and when we have no stones, it'll swap players. That's looking right. Now let's test if we move to the left and we don't drop all of our stones. That actually puts us at a movement event 5, which we have to do the new logic for, but that's looking right. And then the last thing we can do is move into a stone space and drop all of our occupants, at which point pressing enter swaps our turn. That's all looking right. Nice. So now we can kind of move stones like this. It's looking right. Oh, look at this. That's wrong. This is... What's wrong here? Stack control. Oh, we need a flush stack control. We need a flush stack control and stone control upon leaving a space. So we need to I think I'll save this for next episode, and what we're gonna do is actually write a function. We actually did this. I'm gonna write us a function. Write function to clear stack control, stone control, occupants. Well, it's really just occupied. Because just like how we were flushing our grid to be no longer occupied, if we look at this, we are technically occupied here still. Which is a little weird to me. Yeah, we're not flushing any of the spaces. We'll need to fix that. I think we need to do where are we doing the movement origin occupied gets false? Where are we doing that? Right here. So we need something like this, where we say if enter is pressed and we're any of these things, you know, if we're not off grid, then if we have no occupants in our movement origin, no, this isn't right. This isn't right. No, that is right. That is right. Basically, this is saying if the grid we're moving our stones from has no occupants, then we need to flush our occupied, our legal move highlight, but we also need to flush stone control and stack control. So we need to say this. We need to say stone control gets reset, and our stack control gets reset. Now we could add this to our player swap reset, which actually, yeah, are we not doing that? Stone control, stack control, and our reset. Where are you? We do not flush stone control or stack control or dot occupied here. So this is actually the place to do it. Because this would be meaning we just finished a move, therefore we need to... Actually, yeah, no, it's different than that. Actually, if we do it before we reset our movement origin and stuff, we should be able to pull it off. I guess let's try it, so we don't have to do this all kinds of lines of code all the time. We're gonna say, see, but it's in a, it's only if a specific thing happens. Okay. I don't know the best way to do this, but let's just say for now, we can turn this into a function saying, if our milestone occupants are 0 by the time we press enter and a legal move has been executed, or whatever you want to call it, if one of these blocks are executing, we need to, before we swap the player, we need to just flush those values if we move out of our movement origin grid, meaning we moved all of our things out, then we need to flush all these things. And I'm pretty sure stack and stone control start off as nil, so that should be okay. And we just need to do that right here before we swap our movement event. So now maybe that thing will be fixed. I'm just going to check that our stack and stone control are initialized to nil. See, and this is actually because they're not in the play state, they're actually in our member stack. Actually, no, they're not. Stack control, stone control here in our occupant, and they are nil. So let's see if that is fixing our problem of stack control still being populated even though we move all our stuff out of there. So we hover over it, no longer stack control, no longer stone control, no longer any occupants. So I'm just going to place a couple of things here and kind of stack some stuff to test. It's looking right. It's looking right, boyos. It's looking right. Occupants 2, yeah. Occupied true. Yeah. It's looking right. So like we dropped 2 black stones in this place here, and this is something we didn't fix before we started refactoring. See how this like double thick? That means there's 2 black stones there. You just can't see them because black on black is invisible. But technically we could let's say we move down to here and then we move over here. Now there'd be 3 black stones, and you can't really tell that there's 3 stones there kind of looks like a stack order of 4 stone on top of 1 stack order of 1 black stone. So we'll have to either render a thin white outline on the black stones and a thin black outline on the white stones, or a thin white outline on thin black line on a white stone and thin white line on a black stone. I held off on that because the adaptive rendering makes the code for that a little wonky. I'm sure we could figure it out. It won't be too bad. So that's one thing on our like polishing up list that we have to make sure we do. But it's looking like our movement event 4 is done. So we can say here to add outline to stones to see same color stack. We know we need to do that. But other than that, I'm pretty sure we finalized our stack or our movement event 4. So if we take a look at our movement event 4, it's now this big, which looks a bit bigger than the other ones. I guess let's leave some comments. This is assigning next move, assigning our next movement grid, basically. And then this is dropping stones, picking up stones. It's all pretty much self-explanatory, actually. I don't really think I need to comment any stuff there because I kind of just get it. Because this would be if... Yeah, I mean, I think it kind of speaks for itself, honestly. I'm gonna remove this. Okay. Let's just double check, make sure nothing broke before the commit. Okay, I think we're good. You know what? I'm kind of curious if we can move a standing stone or not. Oh no, you can move a standing stone in the game. Yeah, you can move a standing stone and a capstone. It's just that you can't move on top of a standing stone. But yeah, you can move a standing stone, so I think we're good. We take a look at our git diff real quick. We've got 5 new variables. We've got off grid, we've got next move row, second movement row, which are technically the same thing. I just didn't want to conflate them and have bugs, but we're on our 3-stack tester. We just changed to grid, so that's a bunch of nonsense. But we reset a couple of things in our player swap reset. We added a 3rd debug option. We fixed a bug that we didn't realize until we swapped our tester location. We added, we updated our next movement grid to detect whether or not it's off grid or not. Where the next move is off grid, and then we added the logic for every possible combination from movement event 4. Those combinations are: we drop all of our occupants and and our grid is not off grid, meaning our next move wouldn't be off grid, but we drop all of our stuff. Or if we are off grid, we make sure we drop all of our stuff before we swap players. And then the last thing is, if we are not off grid and we haven't dropped all of our stones, then we need to increment our movement event, and then we're ready to code our movement event 5, which there's only 7. So once we hit 3 more, we're basically done with the game. We need to figure out win state after that, but the hardest part of it would be done at that point. And then a bunch of debugging 3 options. So quite a bit of lines, but it wasn't too hefty in terms of a commit, but it's actually pretty good line per time ratio. Better than I normally do. We're gonna get at everything with a commit message saying finalized movement event 4, right? Because we're on 5. Finalize movement event 4 logic. I don't want to say finalize, I just want to say I don't know, finish movement event 4 logic. Which we started yesterday and we finished it today. Push it. It wasn't really that many insertions and deletions. A lot of it was because we find and replaced a lot of our tester array index, so it's not that impressive, but we did good. We're on to movement event 5, at which point we just have, look at this, yeah, movement of 5, 6, and 7, and then we're done. We're done with all of our movements. Then we just need to worry about play state and then all of our polishing bugs we want to do. I thought it'd be cool to do in every movement event, it'll print out on the screen the controls and what you're expected to do, because it's straightforward to me because I wrote the game, but it's not so straightforward to have to hit enter as soon as you pick up a whole stack in your control in order to see the legal moves, because you have to lock in how many stones you pick up, and that might not be apparent. So I'm planning on doing like a little help screen on the right that says, if you're in movement event 1, it'll say use up and down to decide how many stones to move, and then hit enter to select the grid you want to move in, and then continue the help to kind of verbally describe to the player what they need to be doing on that turn. And then maybe we make that toggleable, I don't know, whatever, but we'll get to it. We already get pushed, so we're good to go. I will see you guys tomorrow, and we will start on our movement event logic. Yeah, looking forward to it. We're almost there. This is the home stretch of this game. Then we'll be back on Joust, finishing that, and then we can start on new projects. This will be nice and fun. Thanks for watching.